Welcome to this video on cross-language link time optimization, or LTO for short. Today we're going to explore how to do LTO on Windows using clang-cl and Rust. This topic is particularly interesting because it allows developers to optimize their code across different programming languages, resulting in faster execution times and smaller binary sizes. In this video, we'll cover the basics of LTO, its benefits, and then dive into a step-by-step explanation of how to set up and use clang-cl and Rust for cross-language LTO on Windows. By the end of this video, you'll have a solid understanding of the concepts involved and be able to apply them in your own projects. To start with, let's define what link time optimization is. In simple terms, LTO is a technique that allows compilers to optimize code at link time, rather than just at compile time. This means that the compiler can analyze the entire program, including libraries and object files, and apply optimizations that wouldn't be possible otherwise. One of the main benefits of LTO is that it enables whole program optimization, which can lead to significant performance improvements. Additionally, LTO can also help reduce binary sizes by eliminating unused code and merging duplicate functions. Now, let's talk about clang-cl. clang-cl is a compiler driver for Windows that provides a drop-in replacement for the Microsoft Visual CTAE compiler, cl.x. What makes clang-cl special is its ability to perform cross-language LTO using the LVM infrastructure. To set up clang-cl for LTO on Windows, we'll need to install the necessary tools and configure our environment. First, we'll need to download and install the LVM toolchain from the official website. Next, we'll need to add the LVM bin directory to our system's path variable. With clang-cl installed and configured, let's move on to Rust. Rust is a systems programming language that provides memory safety guarantees without using garbage collection. What makes Rust interesting for LTO is its ability to generate object files that can be optimized by the LVM toolchain. To use Rust with clang-cl for cross-language LTO, we'll need to create a new Rust project and configure it to output object files instead of executable. We can then pass these object files through clang-cl's LTO pipeline to optimize them along with our C or C code. To summarize the main points covered in this video, link time optimization, or LTO, is a technique that allows compilers to optimize code at link time. clang-cl provides a drop-in replacement for the Microsoft Visual CE compiler and enables cross-language LTO using the LVM infrastructure. Rust can be used with clang-cl for cross-language LTO by generating object files instead of executables. That's it for today's video on cross-language link time optimization on Windows using clang-cl and Rust. We hope you found this explanation informative and helpful. If you have any questions or would like to share your own experiences with LTO, please leave a comment below. Don't forget to like this video and subscribe to our channel for more content on programming and software development. If you're interested in learning more about LTO or trying it out yourself, we encourage you to explore the LVM documentation and experiment with different projects. Thanks for watching.